Session, I would like to discuss about the shear force and bending moment, which is the part of unit number 2 of strength of materials. Now, what is shear force and what is bending moment, and what are the different types of problems that we solve in shear force and bending moment? We'll see. Now, consider a beam, and this beam is supported at two ends, for example. And this beam will be made up of various materials: aluminium, copper, steel, and etc. Now, if you apply the force on the beam lateral to the axis of the beam will deform and deflect. The beam will deform and deflect. So it will take this shape after application of the load. Now, after deforming, the beam will be in equilibrium. So if you take any cross section A along length of the beam, and if you draw the free body diagram, it will be like this. So this is called shear force. At the cross section, the beam will be in equilibrium by two opposite forces, that is called shear force. Now this shear force will vary along the length of the beam. So for the beam problem, we have to draw shear force. We have to draw shear force. And next, bending moment. Now the bending moment, the force multiplied by distance is the moment. At any point, which is at a distance of x from one end, the moment about the particular section is called bending moment. And this bending moment also will change along the length of the beam. So that is what is called definition of shear force and bending moment. Now, in the unit number 2 of strength of materials, we'll see the different beams, like a simply supported beam, one end fixed support, another one roller end, with several forces, F1, F2, F3, like that. For this, draw shear force diagram and bending moment diagram. For the same problem of simple beam with fixed support and roller support, we have uniformly distributed force up to some distance and several forces at various locations, F1, F2, and so on and so forth, and uniformly distributed load. For this particular beam, draw the shear force and bending moment. So this is about simply supported beam. And now, the simply supported beam will be having fixed at both the ends, or fixed and simply supported at other end. So in these cases, we have the combination of uniformly distributed load forces, F1, and varying load, uniformly varying load. So for this case, draw shear force and bending moment. And the other type of beam is cantilever beam. This cantilever beam is fixed at one end and free at other end. This particular beam will be having uniformly distributed load, uniformly varying load, and several point forces. Uniformly distributed load, uniformly varying load, and F1, F2 point forces. For this particular type of beam problem, draw the shear force and bending moment diagram. Okay, so this is the part of unit number 2, and after this unit number 2, we have to determine the deflection and deformations. So the deflection will be unit number 3, and the deformation we have bending stress and shear stress. Bending stress and shear stress. Now the bending stress equation, bending moment at any point, any section divided by moment of inertia of that particular section is equal to bending stress at that particular point, so the section, by the distance of from the axis of the beam divided by modulus of velocity by r. So this derivation will be there, and after determining bending moment from this from various beams, we will determine the bending stress at any section above the axis of the beam and below the axis of the beam. And r is the radius of curvature of the beam. And this particular E by R will be useful in determining the deflection of the beam. So that will be unit number 3. And similarly, the shear stress, the shear force, if you consider a rectangular block, so we will be having shear force F and shear force varying in the along length of the distance, and above and below there will be some shear stress will be there. So here then shear stress will be determined. Shear force and bending stress and shear stress. This is all about in unit number 2 of the strength of material subject, and the topic is shear force and bending moment and determination of bending stress and shear stress. That is what I would like to discuss in a small video session. Thank you very much.